Hello everyone, welcome to lesson 11 of our math review series for GRE. Today we'll be looking at circles. So probably everyone has seen circles in their lives. It's a pretty simple figure, just a round figure, and usually on GRE they will tell you where the center of the circle is. So here point O is the center of the circle. Now there's some line segments that you can draw in the circle. The first one that you need to know is the radius. So if you draw a line from the center of the circle to the edge like this is known as R, the radius. And as you might imagine, you can draw many radii in the circle and they are all equal in length. Okay, so that's the first line segment. Now the other line segment that you need to know is the diameter. The diameter goes from one edge of the circle to another edge through the center. Okay, so let's say one edge, the point is A, the other is B. AB is the diameter, and you can see that the diameter is twice the radius. Okay, so radius goes from the center to the edge, diameter goes from one edge to the another edge to the center. Okay, the other line segments that you need to be aware of are those that go from one edge to another edge, but they don't pass through the center. So these are known as chords. Okay, so again, edge to edge, but they don't pass through the center. Okay, so one thing to know is that all diameters are chords because they're going from edge to edge, but it's a special chord since it goes to the center. Okay. Another important fact to remember is that diameter is the longest line that can be drawn inside a circle from one edge to the other edge. Be drawn inside a circle. Okay, so no other line in the circle, inside a circle, can be longer than the diameter. Okay, this fact is pretty important, and GRE would test you on this every now and then. Okay, one more interesting fact. So since circles are very unique, let me draw one circle again here. So all right, here's a circle, close to a circle. Let's say this is our center O. Now if I draw a triangle inside this circle such that two of the sides are radii, okay, so these are the radiuses, right? They would be equal in length. And if I draw a triangle such like this, okay, so I have two lengths, that's the radius, and the third length is here, third side of the triangle is here. This is, as you can see, there are two sides equal. This is always an isosceles triangle. Okay, so these triangles are again very common. These triangles that are inside a circle like this are very common, and they're always isosceles triangles since two of the sides of the triangle are radius, which are equal in length. So then you have two angles, this and this, which are equal. So let's say if I tell you one of the angle lengths is 70, then this would be 70. And I know since all the angles inside a triangle have to add to 180, this angle would be 40 degrees. Okay, so these triangles are very common, and it would be good to pick them right off the bat, since you know the two radii become the sides and the triangle has to be isosceles. Okay, some other circles to remember. So if I take a part of the circle like this, so let me draw the circle first. So here's the circle, and I take a part of the circle like this. So I draw two radii to the center. These are my two radiuses, and I'm only considering this part of the circle. Okay, you see the angle here between the two radii is 90 degrees. This part is known as quarter of a circle. Okay, You can draw 4 of these in a circle, and each of this is known as a quarter circle. Okay. Another one to remember is a hemicircle. So let me draw it better. So hemicircle is just half a circle. Let's say this is the O, this is the center. So this is known as a hemicircle. Okay. So these terminology every now and then show up on the GRE. So it's good to know what they mean. So hemi means half. All right. Okay, let's do an example problem now. Okay, so here is a quantitative comparison question. We have a circle, and the question says O is the center of the circle, and AB is the diameter. So we have AB diameter, we have 2 other line segments. These are, as you can see, chords. They don't go to the center. So we have a chord CB, we have a chord DB. Okay, so question says quantity A is average of BC and BD. So BC and BD, the 2 chords, and they're asking for the average length of BC and BD. Quantity B is AB, the length of AB. So AB is just the diameter, right? So basically, you're comparing the diameter to the average of BC and BD. Now, we just learned that the diameter is the longest line segment inside a circle. Okay, so diameter is greater than both BC as well as BD, right? So it should also be greater than the average of BC and BD. So the average of BC and BD cannot be greater than BC or BD, right? So that clearly tells us quantity B is greater. Okay, so simple, no calculation needed. We just need to know the fact that AB, or the diameter, is the longest line segment inside a circle. Okay, all right, let's look at some other concepts. Okay, I'm going to write over here. All right, so first is area of a circle. So area of a circle is given by pi r square. Okay, and so r is the radius, pi is a special constant whose value is always 3.14. Okay, so if you know the radius, the area can be easily calculated using this formula. Another quantity that you need to know with regards to circles is the circumference. The circumference is like the perimeter of a polygon. It's basically your length of the edge of the circle. So if you have a circle, okay, and you measure all the way around, so you start from here and you measure the length of this edge all the way around. So the way you would do it, you can take a thread and just put this thread all around the edge of the circle and measure the length of the thread. Okay, so that is known as circumference, very similar to perimeter. So this is given by 2 pi r, 2 times pi times r, the radius. Okay, so formulas that you need to memorize. Okay, memorize these formulas. Area is pi r square, circumference is 2 pi r. Okay, let's do an example problem that uses these quantities so that you can get a better idea of what they represent. Alright, here is the first problem. A square of area 2 is inscribed in a circle. What is the area of the circle? Okay, so first of all, we have a circle. So let me draw a good circle here. Okay, that's a decent circle. Let's say this is the center of the circle. And says a square of area 2 is inscribed. What does this word inscribe mean? Inscribe means that you're putting a square inside the circle, but it's a special square inside a circle. It's such that the edges of the vertices of the square lie on the circle, on the edge of the circle. So see, this vertex, the third vertex, the fourth vertex, they lie all on the edge of the circle. So this is when a square, or for that matter any other polygon, when it's inscribed in a circle, all its vertices are on the circle, on the edge of the circle. Okay, so it says that square, area of square is 2. Okay, and we want to find the area of the circle. Okay, so the area of the circle is given by pi r square. So can we find the radius of the circle, so when you have a polygon like this, or a square inscribed, what happens is that the diagonal of the square passes through the center, and it's actually the diameter of the circle. So what I'm trying to say is that the diagonal of the square is equal to the diameter of the circle. Okay, so this way we can find the diameter, and once we have the diameter, we know the radius, we can find the area. Okay, so my square has an area of 2. If I say the side length is s, then I know the square area is given by s square is 2, then the side is root 2 if I take the square on both sides. Okay, so I know my side of the square is root 2, root 2. Okay, now if I know that the side is root 2, the diagonal is given by root 2 times root 2. Okay, again, these are common properties that we had reviewed in the last lesson, in the previous lesson. So make sure you know how to calculate the diameter of a square, so the or the diagonal of a square. Okay, so diagonal is root 2. I know now I can find the diameter. The diameter comes out to be 2. So if the diameter is 2, then the radius is half of that, so radius is 1. So now I have the radius of the circle. I can plug it in here for the area of the circle, and I get pi. Okay, all right, so never plug in the value of the pi unless the question forces you to do that. So see, over here I didn't plug in 3.14 for pi. I just get the answer to be pi, and here in the answer choices there's a pi in there. Okay, so C is the correct answer. All right, let's do another question quickly, which is a bit more complicated. Okay, so here is a quantitative comparison question. We have two figures, A, B, C, D, and E, F, G, H, R are squared. A, B, C, D, this is a square, E, F, G, H is a square. And all the circles are tangent to one another. Tangent, that's an important word. And to the sides of the square. Tangent means that the circles, like this circle and this circle, they touch at only one point. Okay, so that's the tangent. What tangent means, they're touching, two figures that are touching at only one point are tangent to each other. And it says the circle is also tangent to the square, which means that it's right over here, it's only touching the square at one point. Right here it's touching the square at one point. Okay, so the circles are tangent to each other, they're tangent to the square. All right, and the same for figure 2. Quantity A says the area of the shaded region in figure 1. Okay, so the shaded region is this part, basically anywhere where you don't have the circle is the shaded region. This part, this part, this part. So you want to find the area of the shaded region here. Quantity B is the area of the shaded region here. Similar here, you have, okay. Alright, so here you have four big circles in here. Here you have 9 circles inside the square. The squares have the same length in both cases, 12, 12. You need to find what is the area of the shaded region. Okay, so area of the square is easy to calculate, right? Area of the square is just 12, the side square is 144. Okay, let's look at figure 1. So if I find the area of the circle, then I can subtract that area of the circle from the area of the square, and I'll be left with area of the shaded region. Alright, so how do we find the area of the circle? So here's one line segment that I can draw. So I know this is, let's say these are the centers of the circle. If I draw a line segment like this, okay, So it's going through the center of the circles. The circles are tangent, so this line segment, they have to go through the center. And it's also equal to the edge. The length of this line segment seems to be equal to the edge of the square, which is 12. Okay, which means the diameter of each of these circles has to be half of the edge of the square. So 6 and 6. Okay, so now basically if the diameter is 6, the radius would have to be 3. So now I can find in figure 1 area of each of the circle to be pi 3, which is a radius squared. That gives me 9 pi. Okay, so now area of the shaded region is just the area of the square, which I found to be 144, minus area of all the circles. So I have 4 circles here, and each circle, the area is 9 pi, so I'll have 4 times 9 pi. So my area of the shaded region comes out to be 144 minus 36 pi. Again, I'm not going to plug in the value of pi here, I'll just leave it like this. Okay, let's do the same for figure 2. Again, I want to find area of the circle. For that, I need to know the radius of each of the circle. So again, I'll draw a line segment that goes to the center of all these circles, and this would equal to 12. Now this 12 is equal to 3 of these diameters. So I have one diameter, I have the second diameter, I have the third diameter, right? So 12 divided by 3 gives me 4. So each diameter is 4. Okay. Excuse me. So the diameter is 4, then the radius would have to be half of that, which is 2. Again, see, you draw this line segment, and the line segment has to equal to the side of the square, and it's also equal to 3 of the diameter. So each diameter is 4, radius is 2, 2 square gives me 4 pi for area of the circle. Now the area of the shaded region is again the area of the square, which is 144 minus 9. So there are 9 circles here, so 9 circles, and each circle is 4 pi. Okay, so I get 144 minus 36 pi, right? So this is quantity B, this is quantity A, exactly the same. Let's see. Again, important, you don't have to plug in the value of pi, right?